Welcome to this lecture on integral sustainability assessment and multi-criteria analysis. This is the last step of a bioprocess design, final designs and selection, which ideally should be based on the integral performance of the three dimensions of sustainability, especially considering that at this point we already have the results on techno-economics, environmental, and social impacts. The triple P concept, people, planet, and profit, provides a clear representation of the ultimate goal of designing sustainable bioprocesses and bio-based supply chains, which, in simple words, would be finding the balance among these three pillars. Different design alternatives would lead to different performances on the technical, economic, environmental, and social indicators, and each design would have its own strengths and weaknesses for each dimension of sustainability. These differences can be used to progressively select and discard alternatives in a sequential manner. Then the remaining alternatives can be compared to each other from an integral sustainability perspective where the multiple dimensions are simultaneously considered. Let's start with the combination of economic and environmental dimensions. This is possible with the eco-efficiency factor, which refers to the ratio between the total production cost and the environmental impacts generated. This factor is then normalized with respect to a reference system or a benchmark, and when comparing our design's alternatives, we can identify four regions. Any system with lower production cost and lower environmental impacts is already better than the benchmark. But an alternative with lower environmental impacts and higher production cost would need improvements on the economic performance. Something similar would happen to systems with lower production cost and higher environmental impacts. In this case, the environmental performance should be improved. In the case of systems with higher production cost and higher environmental impacts, it is better to go back to the whiteboard and develop new alternatives. Now, for the combination of the three dimensions of sustainability, several initiatives have been developed to standardize sets of indicators covering the three pillars of sustainability. One example is the Global Bioenergy Partnership, GBEP, where multiple themes have been considered per dimension, resulting in 8 impact categories or performance indicators per dimension. And if you take a close look at both the themes and indicators, you will notice that many of them have been covered in previous lectures on techno-economic evaluation, environmental impacts assessment, and social impacts analysis. Another example is the standard from the Roundtable for Sustainable Biomaterials, RSB, which considers 12 principles across the three dimensions of sustainability, with a total of 39 assessment criteria, and for each criterion, the minimum requirements for certification of sustainable operations along the entire supply chain are described. As you can notice it, at this point, there are multiple options to select impact subcategories and indicators to assess the three dimensions of sustainability, but in most cases, the final selection will be case and context dependent. But then, once we have the results on the different performance indicators for the three dimensions of sustainability and for each process or supply chain alternative, we can present this information to the stakeholders or decision makers to discuss the sustainability trade-offs. As mentioned before, each design has some strengths and weaknesses, and they can be compared to per indicator and per design alternative using either spider or radar diagrams. These diagrams are handy and flexible tools to compare, for example, just one dimension of sustainability, like social impacts, for two or more supply chains. This visual and participatory approach is recommended when the design and the decision-making teams aim to be more inclusive with the potential stakeholders. An alternative for integral sustainability analysis is the multi-criteria optimization. In this case, the final selection of processes or supply chains is formulated as an optimization problem for a single score index that aggregates the performance indicators or impact indicators through the use of weighing factors. And these factors can be aggregated or can be agreed with the stakeholders. The weighing factors could be assigned in a one-level approach where all factors are considered at once regardless of the sustainability dimension, meaning that the summatory of all weighing factors would be equal to 1. Or through a two-level approach where the weighing factors are first assigned per dimension, meaning that the summatory of the factors belonging to one dimension would be equal to 1. And then, in a second level of aggregation, additional weighing factors are assigned to each dimension of sustainability. Please notice that the summatory of the weighing factors per dimension should also add up to 1. These two levels are represented in the formulation of the optimization problem as a double summatory. In this way, we have a sequential, inclusive, and systematic approach for conceptual process design, screening, and selection of alternatives based on comparative analysis on technical, economic, environmental, social, and integral sustainability aspects to finally come to processes and supply chains with the best integral sustainability performance, where stakeholders could be part of the design and decision-making process. I hope that the contents discussed this week have enriched your toolbox and broaden your perspective on the design of new bioprocesses and supply chains that go beyond the techno-economic feasibility by making you more aware of the potential environmental and social consequences from the large-scale implementation of your designs. Thank you for your attention during this week.